Okay, let's start to complete the first chapter for the I/O. So I flashback the old one, the last chapter. We have to go to this one first before we go for the programming part. So last time we talked about the memory, the RAM, ROM, and the EEPROM. So let's look at the RAM. So before that, the ROM is for your file to be burned. The process that when you burn your program, your hex file, it will be placed in the ROM. Okay, your hex file will be placed in the ROM. Then you will have the RAM. Okay, let's look at the RAM. This is the organization of the RAM inside the microcontroller. So the one that you played last class is basically two registers. They call it registers again. Register is daftar. So you play around with the microprocessor last time for the register D1 to D7, address register, blah blah blah. So this is called register also. So look here. This is the whole RAM that you have in the microcontroller. It's divided to each location. So there is a function for lots of them. Alright, the one that you play around last week and last class is about tries. D-R-I-S. That is the name of the command, the syntax that you use, tries A, tries B, tries C, remember that? So that is actually a register inside the microcontroller RAM. Example here, look at carefully over here, where's the tries? Here is a tries A, tries B, tries C, tries D, and tries E. This is the name of the register. When you execute tries A, you are actually putting the value inside this register. And this register is related to the declaration of your input output for that particular port. For example, tries A, if you change the value for tries A, for example, tries A is equivalent to 0 binary 1111 0000 is also equivalent as, if you change to decimal, what will the number? 11110000. Can I have the calculator? If you change from binary to decimal, this is the number. Tries A. What's the number? 11110000. Change decimal. Is this the number?
240.
Sorry?
240.
240. So you can put also as 240 in decimal, or you can also use hexa. Hexa is like this. 0 times, this is F, this is 0. You can write down differently in three particular base. It's the same thing. Can I say, for example, like tries A, you put 0B 1111 0000. This is much better for you to look because it resembles the pins on the port A. For example, right? So port A, this is RA0, and last one is RA7, the whole 8 pins. Example, right? If you declare it as 0, that means will be declared as output. If you declare it as 1, that pin will be declared as input. So that is the most important thing first. So for me, it's better for you to declare by using binary numbers because it's much simpler for you to look. If you put like this, you have to figure out which pins is output, which pin is input. Same goes to here. Alright? The last one that we used last time, the example that we used is like this. Thrice B is equivalent to 0. This is the one that we learned before. So it's actually equivalent to this one. 0, 0, 0, 0, 0, 0, 0, 0. So means that you actually declare the whole port as the output. So you have to remember that. If you put like this, you are declaring the whole thing. Okay? If you want to use as output, doesn't matter. Like for example, on the port D, the one that on the board, port D is all connected to the LED. The LED is your output. So it doesn't matter, you can just directly declare it as output. That's all. Okay? That is very important because on the board, they have already the design on the board. So you have to follow the design because it's already connected, hard coded. Okay, the next one. After tries, we play around another command which is port command. P-O-R-T. Can you see anything from the memory over there? Another command is port. The register for the port, where is it? Here. So the port is also another register, which is also divided into four, around 5, sorry, A, B, C, and D. A, B, C, D, and E, sorry. Okay, so you have tries, we have port. When I say port, there may be two meanings. One, I say is the port A is a port. That is the port, the name of the port. But when I ask you to do the port command, that is another thing. Port command means if you port A is equivalent to 0B, 0, 0, 0, 0, 0, 0, 0, 0, what does it mean? Thrice, thrice is the one. Now it's a port. Just now you learned about thrice A. Thrice A, example, thrice A, this is to declare as output. So right now, after thrice, you normally have this particular command, port. So what is the importance of this command?
Declare the pin use.
Any guess? Your board, your microcontroller legs basically, for example, this is port A. Let's say I say just port A, right? Port A. That is a level value of voltage. If you have voltmeter over here, go to the ground. If you don't declare anything, it might have voltage. The voltage for each of the digital output must be from 0 to only 5 volt only. This is your digital value volt. Digital must be 0 and only 1. 1 and 0 for your board, for your particular PIC. So what does it mean? This port command, if you look at 0, which means that the pin will be pulled down to 0 volt. Must pull down. So it means that if you have a voltmeter, if you have the voltmeter and you measure between this pin to the ground, the value will be 0 volt. So there is no LED can be turned on. You turn off everything. So you make sure that the whole voltage is very low. That is the purpose of that one, the port command. So let's say for example you change it to 1, 1, 1, 1, 1, 1, 1, 1. So what is it? You actually pull it up. So it means that if you give this command and you measure the voltmeter, you measure the volt between that particular pin to the volt to the ground, you will get 5 volt. Only for output. Input you cannot set. Input must be outside punya value. So if you declare it as output, so you can set up the current state of the voltage. One means you set up as 5 volt. If you put 0, the particular pin will be only 0 volt. That's why you can see that if you put port A or port D as 0, there's nothing on the LED. If you change it to 11111, you can see that later your LED will be turned on directly. So that is the particular state. You can change the state of the voltage level instead. So that is the two command that you learned last week, last lecture. So this is the one that we changed, the port and the trace. Okay, so I repeat again in this chapter. So this is the thing. What does it mean for I/O ports? I/O ports is all that ports. Port A, port B, port C, port D and port E. That one we call it I/O port, input output port, right? So now this all port can be used to connect to peripherals. Example, on the board you have the LED, you have the motor, you have the switch, you have the buzzer. Today we are going to play with the switch. Switch is not that easy, but if you understand the concept, that will be very important for you to use normally in the FYP. This is normal concept, right? Now we have 5 ports. For PIC 16F, you have 5 ports: A, B, C, D, and E. So this port corresponding to trace register. Just now I tell you guys, trace register. We have trace A to trace E. If the register is set to 0, means it's output, 1 for input. This is the example just now. So you look over here. If you change the value like this, so what is the component that you can use? What is the input? What is the output? Here example, the first one, this one is what? Input. This is a sensor. Sensor must be as input. Switch must be as input. LED as output. This is another switch relay, I think if I'm not mistaken. So you're going to turn on the resistor. This is output. You turn on the resistor, transistor, sorry. So that is actually output and input. Okay, clearly, Okay, now go back to the last one, last semester. Remember this one. The difference between micro C and micro P. You did this one in micro P or not? Do not remember? Cannot remember already? For those who took micro P last sem or you want to totally forget, erase it already. No more in your ROM, no more in your RAM, tak ada lagi dah. Dah blackout lah. This is assembly versus C. Assembly versus C++. If you can remember, the micro P, we have all the command, move here, move there, move here, blah blah blah, move everything. It's not that easy. Assembly is not that easy, but it's very down below. Whereas on C, you actually can understand the syntax, most of it. But no matter what, this is actually the higher level of language. Going down, still assembly. Going down, still assembly. Assembly is still there, but you are going to learn about C. So this is the one that you learn in micro C. You are using it in micro C. So you can look at it. For programming, you must have the void main body. Remember that. Void main body. This one is called main body. You must have parenthesis here. Must have close another parenthesis here. The whole body of the programming. This one you learn in first year, right? Programming. So catch back the whole thing. Then inside here, normally in your microcontroller, you have a loop. They call it a loop. This one they call it while loop. So means that if your command start from the top, going inside here, once it's going inside the loop, it will not going out anymore. So it will keep on consistently looping in this area. This is only one time deal going. This is the one that looping every time on your system. So that's why your declaration on the pin must be normally done in the first paragraph over here, in the first area over here, before you jump to the while loop. So that is the normal process. You declare everything majorly, whatever that you want to declare, on top of the program. After that, then you go down, play around with the software, with the program over here. Okay, you declare here, give the signal value, and this is the programming. This programming basically is to invert the position, the current state value. For example, now your port P now is 0 volt, all 0 volt, so the LED will not blink. Going inside here, this command says your port P now is actually inverting the current port P. Means that your port P 0 invert means all go back to 5 level, so it will delay 1 second. So it will on 1 second and then go up back. Port P is equivalent to invert again. So from 5 volt go to down, wait for 1 second, and then go up here again, invert again. That's why you can see your LED is blinking on and off. So that is the real thing about your programming last week. So this syntax is to invert the value only. Where your port P before that, in the first state level, is given as 0. Means that the whole LED will be going down. There will be no lights on the LED. Okay? Right. You can see this one. Now, this is the one that I gave you just now. If you want to register or declare on the pin, this is the way how you want to declare it by using 0 and 1. And also the port X is the command just now to give 5 volts or 0 volts on the pin. Alright. From port A to port E, the one that you have to remember that the special one will be on port A and port E. Why I say that one is because port A is the normal one that we are going to use for the sensor input. Port B you cannot use it, C cannot use it, D cannot use it. B, C, D is basically the digital output input. Whereas port A, you can configure it as analog input. Digital is digital, right? Digital is like this, 1 or 0 only. 0, 1. Where analog, it can be any value. It can be any value. There's no value such as 1 and 0. It can be any value analog. So your port A is special for the sensor. So after this, you're going to learn about the sensor, the temperature sensor and the LCD. You're going to use in port A, right? So remember that port A. So you must say you have port A and here. RA, this one, RA, for example here now is RA0/AN0. So means that that particular pin for port A can be used either as digital input, output, or analog input only. It can be configured as 2. Up to you want to configure as what. Analog input is only input. There's no analog output. Your PIC cannot generate analog output. They only give you digital output. Okay? Right. Now go further. This is about the TRIC and this is the whole register that we just talked just now. And port E. Another special one is port E. Port E has only 3 pins, can be configured as input and output. You can see that port E somewhere over here. Only this one. Okay. Port E pins are multiplexed with analog inputs. You can see that this was /AN5. So just now we have also RA. Port A can be used as digital input, also as port E. You can choose which one, A or E. Okay. So the TRIC E will control the directions. TRIC E is to control whether it's input or output. Okay. Right. How to use it? That's the one that we keep on telling you in the first program. How to use it. This is how to use it. Try P and port P. And then you have the program. This is only for the output. So today we are going to play with the switch. Okay, right? Okay. Next one is okay. Now, the micro C programming. So, just want to make you guys familiar more on the programming side. So, we have the body here, main body. You have the while one. You have the whole body. This is a must. When you write down the program, you must have these two body, while loop and the whole main body. Okay, you declare it on the main body. Your program must be in the while one loop. So, it will not keep on consistently. That's why if you put this one over here, it will always configure. There shouldn't be things that you need to do. So you have to configure once only. Alright? Next one. This is another method. Last time you also learned about subroutine, remember? You can call any routine, you can call any here like this, you can call this guy. Example here, init main. You can declare somewhere else as the subroutine or function, and then you can call back in your main program. Remember this one last time in your C++, This is the way of writing function. And you have the variables, declare the variables, blah 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 here and there. You have the loop, remember that, for loop, while loop, do while loop. Okay, and then you have conditional syntax, which is if and else, switch and case. This is the example here. Then you have the subroutine function. This is all about C++. This one is okay. So this one very fast, but I hope that you can catch with me. So now, today the task is you have to play around on the board to program your switch. Okay, that is your task. I give you everything first, then you write down, try to figure out. On the board, what you need to do is, when you push the switch button, the buzzer will on. It's just like your door system. You push the button, the bell will on, will alarm, and then when you remove your switch, then the bell will be off. Okay? So the thing like this, on the board, on the board, okay, look here. On your board, this is your PIC, This is a PIC. So I don't want you to go through the manual, I'll give you directly. So this is key RB0, pin port B0, port B.F0. This is the port RB0. This pin on the board is basically connected to pull up switch. That's why I pull down. The switch is over here. Your board, Your board. The pin RB0 is connected to switch 1. You can see that the switch 1 is on the board. From the 3 switches, the left one. Okay. The initial state for your switch is 5 volt. Okay, when you turn on, the initial value, this one is 5 volt. If you turn on your switch, this one will be connected and your value over here will be 0. So this is the active low switch. That is already designed on the board, so I cannot change it. is the hardware. Okay? Right now, you have to check. You have to check this pin by using if-else statement. In your program, you must use if if port B dot F0 is equivalent to 0. Kalau saya tekan dia, if I press this one, is equivalent to 0, then you have your function here. So what you need to do, you have to turn on the buzzer, right? So you have to turn on the buzzer. Else, turn off the buzzer. Right. So now you can see the command, the new command that I use over here is this one. Port B.F0 means that this is actually pin RB0. You can change it to either 1 up to 7. It's up to you. But now you are playing around with only one pin only, which is RB0. Okay, so try to figure out today the board on how to use the switch. Means that if I push down the button, the buzzer will turn on. Last week, you turn on the buzzer, right? So you have to remember that how you turn on the buzzer. Else, you shut down the buzzer, you turn off the buzzer. Or, I want to show you the Proteus. We draw the Proteus right now. You can draw the Proteus right now, very simple. To make your life easier, look at the Proteus. Here. Okay, go for I6. Okay, you can go to the PIC device, PIC16F. And then you also have to take the resistor. And then port B is your switch. So means that you must have a resistor here. And then this one is connected to your resistor. And you must have the power pins, power for 5 volt over here.